So we have covered a lot of fundamental concepts in Angular. In this section, we're going to look at consuming HTTP services. So by the end of this section, you'll be able to connect your Angular applications to your backend services or APIs. More specifically, you will learn how to perform CRUD operations, that is create, read, update, and delete. You will learn how to extract a reusable data service for working with various endpoints, how to properly handle different kinds of errors, and how to build applications with proper separation of concerns. Before we get started, I should let you know that this section is a bit longer than other sections in this course. So it's best if you code along with me during this section, as there are lots of little exercises in between lessons. Also, it's better if you watch the first 40 minutes or so, then get up, have a 10-minute break, and continue watching the rest of the section. So now let's get started. Alright, as I told you at the beginning of the course, Angular is a front-end framework. We build it to use client applications. In most real-world applications, however, we need a bunch of HTTP services on the server, and we use these services to get or save data. Now, as an Angular or a front-end developer, you don't necessarily need to know how to build HTTP services unless you want to be a full-stack developer. So in this section, I'm going to show you a fake HTTP service that we're going to use as the backend for our application. So head over to jsonplaceholder.typicode.com. So this is the homepage of JSON placeholder. When you scroll down, under resources, you can see various endpoints. So we have posts, comments, albums, photos, to-dos, and users. So let's go to posts. Note that we see a bunch of JSON objects here. So each object has 4 properties: user ID, ID, title, and body. So when we hit this URL in our Angular app, that is jsonplaceholder.typicode.com/posts, this is what we get. Now we can send various kinds of HTTP requests to create, update, and delete posts as well. But as I told you, this is a fake service. So let's say you create a new post. The API responds as if the post was actually created on the server. But when you refresh the page, when you get the list of posts again, that new post is not going to be there because there is no database behind this HTTP service. It's just a fake HTTP service, okay? So in this section, we're going to use this service as the backend of our application. All right, now that you know what JSON placeholder is, let me show you how to write code to get all these posts objects from JSON placeholder and display them on a page. So back in VS Code, I'm going to start with a new component called posts component. Now the first step to consume HTTP services is to go to app.module. And here in the imports array, we need to import a new module. That is HTTP module. Let's import this. So on the top, you can see this module is defined in Angular/HTTP library. So all the classes for working with HTTP services are encapsulated in this module. Now let's go to our posts component. Here I'm going to add a constructor. And in this constructor, I'm going to add a parameter called HTTP of type HTTP. Let's import this class on the top. So once again, you can see this class is also defined in Angular/HTTP library. Whether we want to get the data or save the data, we use this HTTP class to send HTTP requests to the backend. Now, before going any further, let's go back to the browser and make sure everything works up to this point. So here's our home page. And in the console, we don't have any errors. Now let me show you what happens if you forget the first step, that was importing the HTTP module. So back in app module, I'm going to comment out this line where we import the HTTP module. Save, back in the browser. Okay, we got this error. No provider for HTTP. You have seen this error earlier in the course. We got this error because here in our posts component, we have injected this HTTP class, but we have not registered this as a provider. So dependency injection in Angular doesn't work unless you register all these dependencies as providers. So back in app module, here in the providers array, we should add the HTTP class. Because this class has other dependencies, and we don't want to list them all here because this is very repetitive and it's not the best practice. So that's why we import the HTTP module. So this module, just like our app module here, is a class defined in Angular. It has the ng module decorator applied to it, and it also has this providers array where all classes used in dependency injection are registered. So by simply importing this module here, all the dependency injection is set up properly. Okay. All right. Now let's go back to our posts component. I'm going to use this HTTP object to send a request to our backend. So http.get, and with this we can send an HTTP GET request to the server. We use this kind of request to get some data from the server. Okay. Now as the argument here, we need to set the URL. So let's go back to the browser. Here on JSON placeholder, I'm going to copy this URL here. So JSON placeholder.typecode.com/posts. Copy. Back here, paste. Now look at the return type of this get method. It returns an observable of response. What is this observable? Well, earlier I told you that we use promises and observables to work with asynchronous or non-blocking operations. So here we're going to go over the network, we're going to call the server, and the data is not available immediately. There's going to be some delay, maybe 10 milliseconds, maybe half a second, maybe 5 seconds, who knows. And during this time, we don't want the main thread that is executing this code to get blocked. Okay? So we use promises and observables, and with these classes, when the result is ready, we'll be notified. Now, promises and observables have some differences. For now, don't worry about them. All I want you to know now is that this observable has a method called subscribe. So we can chain a method call here, .subscribe. And with this, we're basically subscribing to this observable. So when the result is ready, we'll be notified. Okay? Now, this subscribe method has 3 overloads, which basically means there are 3 ways we can use this subscribe method. If you press the up and down arrows, you can see different overloads of the subscribe method. And each overload has different parameters. The one that we're going to use is the 3rd overload here. So here we have 2 parameters, next and error. And as you can see with this question mark, they're both optional. Now look at the type of the next parameter. We have an arrow function here. So this function takes a value, which is a response, and it returns void. So here I can pass an arrow function, response goes to a code block. So this is what we call a subscription function. And here I will have access to this response. So let's simply display it on the console. Response, like this. Now back in the browser. So here in the console, this is our response object. You can see the status is 200, which means okay. We also have these headers here if we need to access them. Now, most of the time, we're not going to use this response object in this raw form. We want to convert this to a JSON object because we're going to use these JSON objects to display data in our views. So back here, this response object has a method called JSON. And with this, we can convert the response to a JSON object. Now in this demo, because we are working with multiple posts, when we call the JSON method, we'll get an array of posts. Let's have a look. So back in the browser, look, we get an array of posts. And here's the first post. We have 4 properties, body, ID, title, and user ID. So back here, I'm going to define a field, posts of type any array. And instead of logging this response.json on the console, I'm simply going to set this.posts to response.json. That's it. Now we can go to our template and render all these posts using a bunch of list items. So let's go to posts list.html. Here I'm going to add a UL with the class list-group. Once again, this is a Bootstrap class that we use for presentation only. It's not required. It's purely for giving our UL a nice look and feel. Now, inside this UL, we need an li with the class list group item. Now, finally, we can iterate over our posts using the ng4 directive. So let post of posts. And then here we can use interpolation to render the title of each post. So post the title. That's all we had to do. Back in the browser. So here are all the posts that we retrieved from JSON placeholder as our backend. Now in your applications, instead of JSON placeholder, you have your own backend. Maybe you build that backend or another developer in the team. But as an Angular developer, all you need to do is to use this HTTP class to send the request to that backend. So this is how we get data from the server. So in the last lecture, you learned how to get the data from the server. Now let me show you how to take this application to the next level and add the ability to create a new post. So here we have a text box. I can add the title here, my new post, enter, and now it appeared here. And also, behind the scene, we sent an HTTP post request to JSON placeholder to create this post on the server. So back in the template for post component, I'm going to add an input with the class form-control. Now, you want to handle the key up event. So key up and also apply a filter, enter. So when the user presses enter in this text box, you want to call the create post method. And as an argument to this method, we want to pass a reference to this input field. So let's add a template variable here, title, and simply pass that to this method. Now back in our component, let's implement this new method. So create post takes the title. And once again, it's good practice to annotate this because this parameter title is not a title object or a string. It's an HTML input element. So we want to avoid confusion for other people reading this code and also improve compile time checking. So this is an HTML input element. Now here we need to call the server. Once again, we need to use this HTTP object here. But this object is currently only available in the constructor. So I'm going to decorate this with the private keyword. So it will be a field in the class. And then here in the create post method, we can call this .http. Now instead of the get method, we're going to use post. And this will send an HTTP post request to the server. So we have a few different types of HTTP requests. Each request has a verb that determines the type of action. We use HTTP get to get data, HTTP post to create data, HTTP put to update data, and HTTP delete to delete data. Now let me show you one simple way to remember this. In HTTP put, we have you, and also update starts with you. So this is how I remember the difference between HTTP post and HTTP put. Now we also have another verb that is HTTP patch, and we're going to look at that later. So to create data, we need to send an HTTP post request to the server. So here, once again, as the first argument to this method, we need to pass the URL. So I'm going to do a small refactoring here. I don't want to duplicate this URL in two places. Instead, I'm going to declare a private field here, private URL. Why private? Because this is only for the implementation detail of this class. Nowhere outside this class, we want this field to be visible. Okay? So I'm going to grab this URL here, cut, and set it here. And then in HTTP GET, I'm going to pass this.url. And similarly, in our create post method, I'm going to pass this.url. Now, as the second argument for this method, we need to pass the body of the request. When calling HTTP services for creating data, the body of the request should be a JSON object, and that's the object we want to send to the server. So I want to create a post object here like this. This post should have a title, and the value of this title should be the value we have in our title input field. So title.value. Now, I don't quite like this code because look, title is set to title.value. It's a little bit weird. So I would rather to change the name of this parameter to input or title input. I prefer input because input is shorter, right? So now we have a post object. And of course here I've set only one property because this is a simple application. In a more complex application, you might have to set multiple properties, or more realistically, you might have multiple input fields. So instead of one text box for adding the title, you might have a form. So then you get the JSON object behind that form and then send it to the server. Okay. Now, as a second argument here, we need to convert this post JSON object to a string. So we use JSON.stringify, which is a native object in JavaScript. Here we pass the post object. Now look at the return type of this post method. This method also returns an observable of response. So all the methods of the HTTP class return an observable, which means here we need to subscribe to this observable, and we'll get the response in our subscription function. So here we add response goes to code block. For now, let's just display this in the console. So console.log response, and we want to convert this to JSON. Okay. Now let's test this back in the browser. Here's our new input field. I'm going to add mosh, enter. Now look at the console. This is the object that we get from the server. So this object has only one property, and that's ID. That's the ID of the new post. In a real world application, when we send an HTTP post request to the server should respond with a complete representation of the newly created object. So instead of one ID property, it should have all the properties of the post object. But because here we are working with a fake service, this is purely for demonstration purposes, not a real API. So back here, I'm going to get the ID that we get from the server and add it in the post object. So post.id, we set it to response.json.id. Now here we have a compilation error because this post object we created earlier doesn't have an ID property. Now there are two workarounds here. One way is to set the type of this to any, and then TypeScript will not complain about this anymore. The other way is to use the square bracket notation. So instead of accessing this property using dot notation, we use square brackets. As far as I know, there are no differences between these two approaches. So now we have a post. Finally, we need to add it to our posts array so we can see it on the view. So this posts, we can call the push method, but with this, our post will appear at the end of the list. If you want to add it at the beginning of the list, you need to use the splice method. So splice, the first parameter is the starting position. So 0. The second parameter is the number of objects you want to delete. In this case, 0. And the third parameter is an object you want to add at the starting position. So here I want to add this post object at index 0. Okay. Now finally, let's clear the input field. So once we set this post object, then we can set input.value to an empty string. Let's test the application. So mosh, enter, and now it's in the list. So to create data, we use the HTTP post method. Now let me show you how to implement the ability to update data. So back in our template, just before rendering the post title, inside the list item, I'm going to add a button. So a button with two classes, btn and btn-default. And we can also make it small, so btn-sm. Let's call this update. Now here I want to handle the click event and bind this to update post method in our component. And as the argument here, I'm going to send the actual post object. Now back in our component. So here's the create post. After that, I'm going to implement update post. So update post takes a post object. And once again, we need to use the HTTP object to send an HTTP request to update the data. Now here we have two choices. We can either call this .http.put, or we can call the patch method. What is the difference? We use the patch method to update only a few properties in an object. So instead of sending the complete representation of that object to the server, we send only the properties that should be modified. It's easier to show you in code. So here, let's say each post has a property called isRead. When we click a post, we want to set that property to true to indicate that this post has been read. Here we can use the patch method like this. So patch, once again, the first argument is the URL. So this.url. And the second argument is the body of the request. So here we want to modify only one of the properties. So instead of sending the entire post object to the server, we send only the properties that should be modified. So JSON.stringify. Here we add an object with the properties that should be modified. So isRead, we set this to true. So this is how we use the patch method. Now, if you want to use the put method, let's duplicate this. Here we change this to put. Instead of sending this object here, we need to send the entire post object. So this is the difference. Now, which approach should you use? That is really dependent upon what you're building. For the starter, you need to check to see if your API supports both the patch and put methods. Usually, most people build APIs that respond to put requests. So patch is not widely supported. But if you have an API that supports both the patch and put methods, you may be better to use the patch method if you're modifying only a few properties, because with this, you don't have to send an entire object to the server. And with this, you may get a slight performance benefit. So here I'm going to use the patch method. And just like the other methods of the HTTP class, we need to subscribe. Here we get the response. And let's simply log it on the console. So response.json. Save, back to the browser. So when I click update, now look at the console, we got this error, 404 not found. Because when you use the patch or put methods, you need to reference a specific post. Look at the URL here. It's JSON placeholder.typicode.com/posts. So we're referencing the entire posts collection. Instead, we need to reference a specific post. So back here, we need to change this URL, append a slash, and then the ID of the post that we're patching. So post.id. Save, back to the browser. Once again, update, look in the console. So this fake API is returning the same object. Now look at the network tab. Here you can see the request to this endpoint, posts/1. All right, look at our request details. So this is the request URL. You can see the request method is patch, status is 200. Now if you scroll down the bottom, in the request payload, this is the object we're sending to the server. So we have a tiny object with only one property, isRead. If we use the put method, the entire post object would be here. Now in this particular application, it would make absolutely no difference because our post objects are pretty small. They have only 4 properties. But if you're working with large complex objects, you may prefer to use the patch method if you're modifying only a few properties. So that's all about updating data. Next, we're going to look at deleting data. So far, we have implemented get, create, and update. Now let's implement the delete functionality. So back in the template, I'm going to change the label of this update button to delete. And here also change the name of the method to delete post. Now let's go to our component and implement this new method. So delete post takes a post object. Again, we start with the HTTP object. So this.http, but this time we call the delete method. First, we need to supply the URL. So this.url, and once again, we need to reference a specific post. So we need to append a slash and then the ID of the post. So post.id. Now note that here we don't have that body parameter because by convention, HTTP delete requests don't have a body. So all we need to send to the server is an HTTP delete request to this endpoint. And then we need to subscribe. Here we get the response. At this point, we can delete this post from our array. So first we need to find the index of this post in the array. Let index equal this.posts.index of post. And then to delete it, we use the splice method. So this.posts.splice. We go to this index and delete one object. Save. Back in the browser. So now I'm going to delete the second item. Beautiful. So now that you have seen all the CRUD operations, that is create, read, update, and delete, next we're going to look at more details about working with HTTP services. All right, now let's take a look at an issue with this implementation. So here in the constructor of posts component, we're calling the get method of the HTTP object to get the posts from the server. As a best practice, constructors should be very small and lightweight. So we shouldn't perform expensive operations like calling the server. Then you might ask, when can we get these posts from the server? Well, components in Angular have what we call lifecycle hooks. So there are special methods that we can add to our component, and Angular will automatically call these methods at specific times during the lifecycle of a component. For example, when Angular creates a component, renders it, creates and renders its children, or when it destroys a component, these are examples of lifecycle events. At this point, Angular will call specific methods in our component if they are defined. One of these methods is ng-on-init. So earlier in the course, when we created a component with Angular CLI, you notice that all our components had something like this, implements on init. So on Angular website, let's take a look at this on init interface. You can see this interface is defined in Angular/core library. And this is the shape of this interface. So this interface declares a method called ng-on-init, which takes no parameters and returns void. And this is the method that Angular will call when it initializes our component. So when we add implement on init to the declaration of a class, we're telling TypeScript compiler that this class should conform with the structure of the on init interface. In other words, it should have a method called ng-on-init. Now here we have a compilation error because we have not imported on-init on the top. So let's import this. Now we have another compilation error. Class posts component incorrectly implements interface on-init. Property ng-on-init is missing in type posts component. Now this error message has a problem because ng-on-init is a method, not a property. So if we simply add a method here, ng-on-init, you can see the compilation error is gone. So on-init is an interface that we refer to as a lifecycle hook. There are multiple lifecycle hooks in Angular. For example, we have onChanges, doCheck, after content init, and so on. Each of these interfaces declare a method with the same name prefixed with ng. So for on-init, we have a method called ng-on-init. Now technically, we don't necessarily have to add this implement on-init on the top. As long as we have a method called ng-on-init defined in our class, Angular will automatically call this when it initializes our component. But we use implements keyword to add compile time checking. So when we add implements on-init, TypeScript compiler ensures that we have a method called ng-on-init. Now I'm going to get all the code in the constructor, cut it, and simply move it here. Of course, we need to add this here because HTTP is no longer a parameter to this method. So here's the lesson. Do not call HTTP services in the constructor of your components. If you need initialization, use ng on init method. All right, so here's our current implementation of posts component. We have these methods here, ng on init, create post, update post, and delete post. There is a problem with this implementation. The problem is that this implementation violates separation of concerns principle. What do I mean by that? Think of a restaurant. In a restaurant, we have different roles. We have a chef, we have a waiter or waitress, we have kitchen hands, we have a manager, and many other roles. A chef is responsible for only one thing, and that is cooking. They don't come and take orders. In object-oriented programming, we have the exact same concept. So our classes should be responsible for only one thing. A class that does too many things violates the separation of concerns principle, and such a class is hard to maintain and hard to test. Now, in this implementation, our posts component is involved in two different concerns. One is the presentation logic behind this view. For example, what should happen when we click the delete button? The item should be removed from the list, right? But the other concern that this class is involved in is getting the data. So it needs to know about this endpoint. It needs to work with the HTTP class. In update and delete methods, it needs to construct this URL. This is a different concern. In a larger and more complex application, it is likely that we're going to work with posts on different pages. So this is not the only page where we display the posts. So in those pages as well, we need to know the URL for this post's endpoint. So if in the future that URL changes for any reasons, we have to update multiple places in our code. Okay? Also, from a testing point of view, this implementation is a little bit harder to test. For example, let's imagine we want to write an automated test for this method, update post. In our unit tests, we don't want to have a live server up and running. So we want to isolate this component and only focus on the logic implemented here. In other words, we don't want to make HTTP calls to the server because this has two problems. The first problem is that if the server is not up and running, our unit tests are going to fail. The second problem is that all these HTTP calls are going to slow down our automated tests. So we want to run hundreds or thousands of automated tests in just a few seconds. And that's why we should never, ever, ever, ever call HTTP services in our automated tests. So what's the solution? The solution is to create another class, which we call a service, and this class will be purely responsible for working with our backend. So if you want to get all the posts, or create a post, or update or delete a post, we're going to delegate this responsibility to that class or to that service. And this will solve the two issues I told you about here. First of all the details about working with this backend is encapsulated in one place. And we can reuse this in multiple places. And also, if in the future this detail changes, for example, the URL, we have to update only one place in our code. The second benefit is that when we want to unit test our component, we can create a fake implementation of this service that doesn't make HTTP calls to the server. And then we can run thousands of unit tests in just a few seconds. So next, I'm going to show you how to extract a service from this code. All right, now to extract a service, first let's open up the terminal and create a new service using Angular CLI. So ng g s for service, and we call this post. So this creates two files inside the app folder. One is postservice.spec, which is our unit test file, and the other is post service. Note that as the warning says, Angular CLI does not register this class as a provider in app module. So when we use this for dependency injection, we're going to get the error no provider. So before we go any further, let's go to app.module. And here in the providers array, let's add post service. Okay. Now the second step. As you can see, Angular CLI adds this service in the app folder. In a real-world application, we often have tens of services, if not more. I personally don't like putting all these in the app folder. I prefer to create a folder called services and put all my services there. So here in the terminal, let's go to source/app, create a new folder called services. Now I already have this here, so let's just move these new files into this folder. So move post.service.star to services. Beautiful. Now let's go to our post component. The first thing I'm going to move to this service is this URL. This is the implementation detail about working with our backend. So cut. And now let's go to post.service. Move that here. Now here in the constructor, we need to inject the HTTP class. So private HTTP of type HTTP. And let's import this on the top. Beautiful. Now let's go back to post component. Next, here in the constructor, I'm going to replace this HTTP parameter with our service. So in our components, we should not inject the HTTP class. This is a different concern. Instead, we should work with our services. So let's change this to service of type post service. And also on the top, I'm going to remove this import statement. That's better. Now let's modify this ng-on-init method. So this first line where we call the get method of the HTTP class, I'm going to cut this back in post service, create a new method, get posts, paste that here. Now you know that this get method returns an observable of response. So we want to return this to the consumer of the service, which is our component. So return. Now back in the component, here we call this .service.get posts. That's all we had to do. Now look at the separation of concerns here. This component is telling the service that, hey, I want the posts. You go get the posts for me. I don't know how. I don't care about how you're going to get these, but give me the posts. And it's up to the service to figure out where to get these posts. Today, it's getting it from JSON placeholder. Tomorrow, we may decide to change the implementation and get the posts from Firebase. Or we may get them from the local storage in the browser. These are implementation details. When we change how we get the posts, our component is not affected. All these changes are encapsulated in one place, inside the service. And if we have 10 other components in our application that are using the service, again, those components will not be impacted by this change. So this is why we have separation of concerns. Just like a restaurant where we have different roles, in object-oriented programming, we have different classes, and each class should have a single responsibility. Now here's an exercise for you. I want you to pause the video and modify the other methods in this class to solve the issue with separation of concern. And then resume the video and see my solution. So here's the create post method. I'm going to get this line where we use the HTTP object, cut, back in post service, create a new method, create post. This method takes a post object, and here we simply return the observable from the post method of the HTTP object. Now back in the component, I'm going to call this .service.create post and give it this post object. As simple as that. Now let's modify the update method. Once again, I'm going to get the first line, cut, back in the service, add a new method, update post, takes a post object and returns this observable. Now back in the component, we're going to call this .service.update post and give it this post object. And the last change. Here in delete post, I'm going to get the first line, cut, back to the service, add a new method, delete post. Now here, all we need is the ID of a post. We don't need to pass the entire post object. So it's better to be more specific about the contract or the signature of this method. So we need an ID. Now we need to modify this. So instead of post.id, we need ID. And then return the observable. Finally, let's go back to our component and call this .service the delete post, and we give it post.id. So now with this refactoring, we moved all the code for working with the HTTP object outside this class. This class has only one responsibility, and that's the presentation logic behind our posts page. And also in post service, you can see that all these methods are about working with this HTTP endpoint. Now, if we go back to the browser, we get this error: no such file or directory, because we moved this service to a different folder and we forgot to update the import statement in app module. So let's go to app.module. On the top, we need to change the import statement. So get the service from services folder. Save, back in the browser, and our page is working beautifully. So far in our implementation, we have assumed that the call to the server always succeeds. But in reality, that's not the case. So here in ng-on-init, we're calling the getPosts method of our service. Let me simulate a scenario where the call to the server fails. So back in post service, I'm going to change the URL to an invalid URL. Let's see what happens. So back in the browser, the list of posts disappeared. But the user looking at this page, they have no clue what is going on. So we need to change our implementation, handle errors, and give proper error messages to our users. When it comes to handling errors, we have two types of errors: unexpected errors as well as expected errors. Now there are three types of unexpected errors. The first type is when the server is offline. So the client sends a request to the server, but the server is not up and running to respond. So that's the first type. The second type is when the network is down. So the server is online, but the client cannot reach it. So when I changed the URL here, I simulated this second scenario. We could not reach this destination. Another type of unexpected error is when we have unhandled exceptions in our API. So the server is up and running, the network is fine, we call the server, but because of a bug, that call fails and we get an unhandled exception. So these are all unexpected errors. Now let's take a look at expected errors. Generally speaking, there are two types of expected errors that we need to handle in our implementation: not found error messages and bad requests. What are these? So back to our application. Imagine there are two users looking at the same page at the same time. User A deletes a post here, but that post is still visible on user B's screen. So if they try to delete that post, the server is going to respond with the not found message. In HTTP protocol, that means a response with the status code 404, not found. Whenever we want to get an object from the server or update it or delete it, it is possible that that API endpoint will respond with the 404 message. So that's why we refer to this kind of error as an expected error. Another kind of expected error is bad request. So imagine we're building a sign-up form. Here we need to put a username and a password and perhaps a few other fields. When we call the server to create a new account, it is possible that we have an account with the same username. So in that case, the server may respond with an error message, which we call bad request, and the status code for that kind of message in HTTP protocol is 400. So the server is going to tell the client that, hey, there is an account with the same username. So this is an example of an expected error. So if there is a problem with the data that the client sends to the server is going to respond with bad request, okay? So we need to change our implementation and handle unexpected and expected errors properly. And that's what I'm going to show you next. All right, now let me show you how to handle unexpected errors. So here in post component, in ng-on-init method, look at this subscribe method. Here we have passed a function for working with the response. Now this subscribe method has another optional parameter. So let me put comma here. You can see the name of this parameter is error. It's optional as indicated by this question mark. And you can see from the type of this error parameter that here we need to pass a function that takes an error object and returns void. So let me pass an arrow function here. Error goes to a code block. And here we can display an alert to the user. So alert, an unexpected error occurred. Now in a real-world application, it's better to use a toast notification instead of the native alert function in JavaScript. These toast notifications are less confronting and more user-friendly. In case you don't know what I mean by this toast notification, think of the notifications you get on Facebook. They just pop up from the top right corner of the screen. They don't freeze the browser. They automatically disappear after 5 seconds. And also the user can immediately close them. Now also in a real-world application, when an unexpected error occurs, we want to log that error. So later we can look at our log and see all kinds of errors that have happened in our application. Now for now, let's not worry about how to log these errors, but to simulate this, I'm going to add a console.log here. So we log it on the console, but this is purely for demonstration. It doesn't work in real-world applications because this console is only inside the user's browser, and we don't have access to this console. So instead of logging this error in the console, we need to store it somewhere in a database on the server. Now here's an exercise for you. I want you to modify the other methods in this post component and handle unexpected errors. You need to write the exact same code. So go ahead and do that, and don't say this is too easy for me, because we're going to modify this code over the next few lectures. We're going to refactor it. And if you don't code along with me, you may struggle a little bit later in this section. So go ahead and modify the other methods in this component. So I've modified all the methods in our post component and added this error handler function as the second argument of the subscribe method. Also note how I have formatted this code. With this formatting, you can clearly see the arguments of the subscribe method. So we have the response and error at the same level. So always pay great attention to the formatting of your code. Treat it like a book or newspaper, so someone else reading your code can easily understand it. Now that aside, let's see how we can handle expected errors. So here in delete post method, we know that it is possible that the post with the given ID does not exist on the server. So our API endpoint is going to return a 404 message. If that's the case, we want to tell the user that this post has already been deleted. So here in our error handler, we need to check the status of the response. So if error dot, now here we don't have IntelliSense because the type of this error, as you can see, is any. So we need to annotate this with the response class. And we should also put this in parentheses, because in arrow functions, whenever you use type annotation, you need to put parameters in parentheses. Now we get IntelliSense and compile time checking. So error dot, and look, we have access to all the members of the response class. So if error.status is 404, we want to tell the user that this post has already been deleted. Okay? Otherwise, we want to display a generic error message and log the error. So I'm going to move this in the else block. Now to simulate this error, instead of sending post.id here, I'm going to send an invalid ID, like 345. Because this fake service has only 100 posts and the ID of the last post is 100. So save, back in the browser, I'm going to delete a post here, and we get this message. This post has already been deleted. Now let's take a look at another example. So I'm going to go in the create post method. Let's imagine this API endpoint responds with a 400 message in case of bad data. So once again, in the error handler function, we need to annotate this parameter with the response class. And then check the status of the response. So if error.status is 400, now here, instead of displaying an alert, let's imagine we have a form. Let's imagine we have a complicated form. Instead, we want to display error messages next to input fields. So earlier in the section about reactive forms, you learned how to add errors to a form programmatically. So if we had a form here, we could type something like this: this.form.set errors. Now here we can pass the error object that comes from the server. So error.json. Just like how we call the JSON method on the response object, we can also call the JSON method on the error object. And this is the error object that comes from the server. So this object potentially has a bunch of key value pairs. Keys represent the fields in our form, and the values are the errors for those fields. So if we have a 400 message, we display the errors in the form. Otherwise, we display a generic error message and log the error on the server. Now this line is not going to compile, and we don't currently have a form here, but I wanted to show you how to handle bad requests. So for the rest of this section, I'm going to comment out this line and simply add curly braces here. So this is how we handle expected and unexpected errors. But there is a problem in this implementation, and we're going to look at that in the next lecture. So as I told you in the last lecture, we have a problem in this implementation. Can you spot the problem? It's right here on line 67 and 68. The problem is the violation of separation of concerns. So earlier, we created a service to encapsulate all the details about consuming the HTTP services on our backend. We introduced this service to hide all this complexity from our component. But look at these lines. Here, we're working with a response object that comes from the server. We're also checking the status of this response and comparing it with the 404 error. This is not the language of our component. This is the language of our service. So we should change this implementation and move this logic inside our service. And here in the component, instead of working with the response object, we need to work with an object that is part of our application domain. Something that is not specific to the HTTP protocol. So let's see how we can change this implementation. So let's go back to our post service. Here in delete post method, if there is an exception, if there is an error, I want to catch that error. And instead of sending the response object to our component, I want to send a different kind of object, an object that is part of our application domain. So first, let's see how we can catch this error. As you learned earlier, this delete method returns an observable. Observable is a type that is part of a third-party library called reactive extensions. And this type has a bunch of useful methods that we call operators. But these operators are not there by default. So if I add dot here, the only methods we have here on the observable are for each, lift, and subscribe, which you have seen before. One method or one operator that we need is catch. And we need to specifically import this on the top. So on the top, I want to import the catch operator on observables. The syntax is a little bit different from the other import statements. So we add import. Now in quotes, we add rxjs, which is the name of the library, /add/operator/catch. Now we have a bunch of other operators, and they are all defined in a namespace like this. So with this, now when we go back to our delete post method and add dot here, look, we have the catch method. But the icon is different. It's the icon of a field, not a method. But this is actually a method. So I'm not sure why we're getting the wrong icon. But that aside, we want to call this to catch the error, and then we need to send a different kind of error object to the consumer of this service, which is our post component. So here, let's add an arrow function. Error, which is of type response, goes to like this. Now here we have a compilation error because this is not a void method. Here we need to return an observable that has an error. So the consumer of this service, in this case, our component, will get that error and do something with it. Now, how can we return an observable that has an error? Well, first we need to import the observable type on the top. So, import observable from rxjs/observable. Now, back in our method, here we have a method, observable dot throw. And this method returns a new observable that has an error. Now, what is the type of that error? The type of that error should be something specific to our application, not the response object. So we need to create a new class to represent application-specific errors. So here in the app folder, under common, I'm going to add a new file. Call it app-error.ts. And here we simply export a class called app-error. With this, we can represent an application error. Now, back in our service, now here as an argument to the throw method, we want to pass an app-error object. So new app-error. Now, it's a good practice to include the original error inside this app-error, because somewhere we're going to get that error and log it on the server. So I'm going to go back to app-error. Here I'm going to add a constructor. This constructor takes a parameter called original error, which is optional and its type is any. Now we can decorate this with the public keyword, and this will be a field in our class that we can access when logging this error. Okay. Now back in post service, we can pass this original error object here. And finally, we need to return this result. And you can see the compilation error is gone. So to quickly recap, what we're doing here is we're catching the error object, which is an instance of the response class, and then we're returning a different kind of error that is specific to our application. Okay? Now we need to change this implementation and check for the status of the error. So if it's 404 or not found, we want to return a different kind of error, because in our component, we need to know if that post exists or not. And we don't want to check the status of the response object. Okay? So back in the common folder, I'm going to add a new file, not-found-error.ts. Once again, I'm going to export a class, not-found-error. I want this class to derive from the app error, because this is a kind of application error, but it's more specific. Okay? So we add extends app error. That's all we have to do. Now back in our service, we can check the status of the error. If error.status is 404, we want to return an observable that has an error, and the type of this error is not found error. Now in this case, I don't want to put the original error here because we're not going to log this on the server. This is a legitimate error, not an unexpected error, okay? We're almost done. The last step. Let's go back to our component. So here, now instead of working with the response object, we're going to work with app error or one of its derivatives. Because in our post service, we are throwing either an app error or not found error. And since not found error is a kind of app error, we can say that essentially here, we're catching a response object and throwing an app error object. So back in our component, the type of this error should be app error. And then instead of this ugly code to check the status and see if it's 404, we can check to see if this error is an instance of not found error. In JavaScript, we have an operator called instance of. So if this error is instance of not found error, then we display this friendly message to the user. Now here is an exercise for you. I want you to modify the code in the create post method. So here, instead of working with the response object and checking the status to see if it's 400, we want to work with application specific errors. So go ahead and modify this code, and you can see my solution in the next lecture. So here in the post service, in create post method, we want to catch any potential errors and instead throw application specific errors. So dot catch, here we pass an arrow function that takes an error, which is of type response, goes to a code block. Now here I want to check the status of this error. So if error.status is 400 or bad request, I want to return an observable that includes an error. So observable.throw, and here we need to pass an application specific error object. So this 400 or bad request is a common type of error. So back in the common folder, I'm going to add a new file, and let's call this bad-input.ts. I want to call it bad input instead of bad request because I want to differentiate from the HTTP protocol. And here we simply export a class called bad input that extends app error. So it's a type of app error. Okay. Now let's import this. Beautiful. Back in our service. So here we pass a new bad input error. And as the argument to the constructor of bad input, I want to include the error object that came from the server, because that error object includes data about the invalid fields. So we call error.json. Now, otherwise, if the status is not 400, we want to return an observable that includes an error. And here we want to pass a generic app error object. And once again, as the argument, we pass the original error object for logging it later. Now finally, let's go back to our component. Now here, instead of working with response, we're going to work with app error. And instead of working with the status 400, we're going to work with bad input class. So if error is instance of bad input, let's import this on the top. If that's the case, then we want to display the errors in the form. Now here, instead of calling .json, we want to get the original error. And then we can use this as the validation errors object for our form. Now, once again, here we don't have a form, so let's just comment out this line. So with this change, we have improved the separation of concerns in our code. And here in post component, no longer we're working with the response object or HTTP status codes. All right, now let's test the application up to this point. So here in our posts component, in the delete post method, I'm sending an invalid post ID. So when we go back to the browser, I expect to see this error. This post has already been deleted. So let's try this. Delete. We get a different error. An unexpected error occurred. Now let's take a look at the console. So here you can see that our API returned a 404 or not found error, but our application is not behaving the way we expect. Look at this error below. Observable.throw is not a function. This is a kind of error that you may see from time to time. So earlier I told you that these observables have a bunch of methods that we call operators. Catch is an example of them. And you also saw that we had to explicitly import this operator on the top. If we didn't do this, we would get a similar error. So here, this error is telling us that we have not imported the throw method. Now in this particular case, we had IntelliSense here, so we could call observable.throw, but the code is actually not imported. So we need to explicitly import this method on the top. So here, right after importing the catch operator, I'm going to import the throw method. So import RxJS add. Now instead of operator, I'm going to type observable. Why? Because this catch is an instance method that is available on observable objects. But the throw method is a static method that is accessible by an observable class. So let's have one more look. See, here we're calling the throw method on the observable class, not an observable object. So this is a static method. Now in observable type, we have a bunch of static methods like the throw method that we use to create a new instance of an observable object. We call these methods factory methods. They're like factories. They create objects. So here on the top, whenever you want to import a static method on the observable type, in the past, you should use observable. So observable/throw. Now back in the browser, let's test the application one more time. Delete. And we get the right message. This post has already been deleted. So this is how we import observable operators and factory methods. Now, as I said before, observable is an entirely different topic. It's a separate library. It really needs its own course. For now, don't worry too much about it. These two methods, catch and throw, are what you use in most of your Angular applications. There are lots of other operators, but you're really not going to use them in every application. They are for really special use cases. All right, now back in our post component, if you look at the other methods in this class, you can see we have repeated these two lines in a few different places. So here in create post method, again, in the else block, we have this alert and console.log. In update post, again, the same two lines are repeated, and also in delete post. This is telling me that something is not right here. These two lines are essentially for handling unexpected errors. Now here we're dealing with only one component, but in a real world application, we're going to have tens or maybe hundreds of components. We don't want to repeat these two lines in every component. So let me show you how to handle unexpected errors globally. So once again, in the common folder, I'm going to add a new file and call this app-error-handler. Now here we want to export a class that is responsible for handling all the unexpected exceptions in our application. Back on the Angular website, let's search for error handler. So here we have a class, error handler, and this is one of the built-in classes in Angular. Now, if you look at the implementation of this class, you can see we have a method called handle error. This method takes an error object, which is of type any, and it returns void. Now, in the default implementation of this class in Angular, Angular simply logs this error message in the console. Now we want to provide a different implementation of this class. And in our implementation, we want to display an error message to the user and also potentially log this error on the server. Now here, if you scroll down, you can see an example. So we have a class called myErrorHandler that implements the default error handler in Angular. And here we have a different implementation of handle error method. So we want to write the same code in our application. So let's export a new class, call it app-error-handler. This class implements error handler. Let's import this on the top. So you can see this is defined in Angular/core. Now we have a compilation error because we have not implemented the handle error method. So let's add that here. Handle error takes an error object, and you can see the compilation error is gone. Now let's go back to our post component. So these two repetitive lines, alert and console.log, I want to take these two lines out of this class and put them in our global error handler. So cut, simply put them here. Now in the future, instead of this alert, we could display a toast notification. And instead of console.log, we could log the error message on the server. So the actual implementation of this method is not going to be only 2 lines of code. It's going to be a little bit more complex. So now we have a global error handler. Next, we need to register this as a dependency or as a provider in app module. So app.module, here in the providers array, we need to register this new class. But we're going to use a different approach. So instead of registering this class in this array like this, app-error-handler, we want to tell Angular that wherever internally you're using error handler, instead use app-error-handler. So internally in Angular framework, there are multiple places where that error handler class that I showed you is used. You want to tell Angular to replace that implementation with this new implementation. So look at the syntax. Instead of adding the class here, we want to pass an object. This object should have two properties. The first one is provide, which is the name of the class we want to replace. In this case, error handler. And the second property is use class. And here we add the replacement, which is app error handler. With this object, we're telling Angular that wherever you're using error handler, instead use this new class, app error handler. Now let's go back to our post component and clean up all the repetitive code. So first, in ng-on-init, I'm going to completely remove this error handling function. So instead of handling the error here, I want the error to propagate in our application, and then eventually it will hit that global error handler. So delete. Much cleaner. Now create post. So here we still want to keep the error handler because we want to check to see if this error is an instance of the bad input class. But we want to slightly change the else block. So instead of displaying the alert and logging the error on the console, we want to rethrow the error. So throw error. If we don't rethrow this error is actually handled here and it will never hit our global error handler. So we need to rethrow it so it can be handled by our global error handler. Okay. Next, let's take a look at update post. So here, like ng-on-init, we can completely remove this error handling function because we don't have a special case. We're only dealing with unexpected errors. Delete, delete. Much better. And finally, in delete post, similar to create post, first we want to check to see if this is a not found error. Otherwise, we want to rethrow the error so it will be captured by our global error handler. Now let's test the application. So once again, here in delete post, we are deleting an invalid post. Back in the browser, let's delete one post here. We get the proper error message. This post has already been deleted, but let's simulate an unhandled exception. Back in post service, I'm going to change this URL to an invalid URL. Now back in the browser, we get an unexpected error occurred. So to handle errors globally, we create a new class that implements error handler and then register it in app module as a replacement for this class. All right, now in our post service, I see another room for refactoring. Look at this create post method. Here, when handling the error, we're checking the status. If it's 400, we return an observable with bad input. Otherwise, we return an observable with app error. We have a very similar code in the delete post method. The only difference is this magic number. So instead of 400, we're working with 404. And also, note that here in update post, we don't have any error handling because we're assuming that this API endpoint does not return any predefined error messages like 404 or 400. But in a real world application, chances are this API endpoint would return certain kinds of errors. So then we're going to have similar code repeated in the update post method as well. So how can we improve this implementation? Well, here I'm going to extract a separate private method called handle error. And instead of repeating these few lines in every method, I'm going to simply delegate that error handling to that new method. So I'm going to add a private method, handle error. This method takes an error object, which is of type response. Now, I'm going to cut these few lines here and move them inside this private method. And by the way, the reason I define this as private is because this is purely the implementation detail of this post service. I don't want the consumers of this service to know about this method. So the consumer of this service currently is our post component. The post component should only be able to work with these methods: delete post, update post, create post, and get posts. I don't want that class to call this new method handle error from the outside. So that's why it's defined as private. Now here in the catch method, instead of passing an arrow function, you're going to pass a reference to this new private method. So this that handle error. And note that I'm not calling this method. I'm simply passing a reference. Okay. Now we can add error handling to our update post method as well. So here I'm going to add .catch this .handle error. Now similarly, I'm going to modify the create post method, but here we're dealing with a different HTTP status code, 400. So I'm going to move this into our new error handling method. So cut. Now we can quickly jump to that method by pressing Shift, Command, and O on Mac and Shift, Control O on Windows. So here in the search bar, we can type handle error. And here we are. So if the error is 400, we're going to return bad input. If it's 404, we're going to return not found. Otherwise, we're going to return app error. Okay. Now let's quickly go to create post method and modify this. So instead of adding this arrow function, we're going to pass a reference to this .handle error. And we can also add this to our get posts method. And this way we have error handling in every single method in this class. All right, so far our post service is in pretty good shape. We have really small methods, very clean. We define this handle error method that we have reused in multiple places. So it's really good. However, in a real world application, we don't have one service. We often have tens of services. So imagine we want to create a service for working with the courses endpoint. With this service, we can create a course, update a course, get all the courses, and delete a course. You can imagine that in that new service, our code is going to look almost identical. So we're going to have a method called get courses. So instead of get posts, we'll have get courses. And there we'll call the get method of the HTTP object, catch errors, and pass them to the handle error method. And this also means we should repeat this implementation, handle error, in every other service. We don't want to do that. So let me show you a better way. We want to extract a reusable service for working with HTTP endpoints. So here in the services folder, I'm going to add a new file, data.service.ts. Now, back to post service. I'm going to copy all this code and simply paste it into this new file. Now on the top, first of all, I'm going to change the name of this class. So instead of post service, it's going to be data service. Now this URL is specific to posts. I don't want to set that here because this class is going to be reusable. So let's delete this initialization. Next, I want to rename this method. So instead of get posts, I want to call it get all. Similarly, I'm going to rename this method. So instead of create post, I'm going to call it create. Now, what about the parameter here? I want to rename this to something more generic. In HTTP services, we often use the term resource. So let's rename this to resource. Next, I'm going to rename the update post method. So let's just call this update. And once again, we rename this to resource. And finally, instead of delete post, we're going to have delete. And this method takes an ID, so we don't need to rename the parameter. So in this implementation, there is nothing specific about posts. Okay? Now, let's go back to our post service. I'm going to delete all the methods here because I defined them in that data service. So delete all the methods. All we have is the URL and the constructor. Now I want this class to inherit all the code that I defined in our generic data service. So I want to use inheritance here. So post service extends data service. Now here we have a compilation error. So this is telling us that these two different types have separate declarations of a private property called URL. So because we defined this URL field in our base class, we should have redefined it here. So for now, let me just comment out this line. We still have a compilation error. Let's have a look. This time it's telling that these two types have separate declarations of a private property called HTTP. So I'm going to change this constructor and remove the private keyword because this field is defined in the base class. Okay, so delete. Now the compilation error on the class is gone, but we have a compilation error on the constructor. Constructors for derived classes must contain a super call. What does this mean? Well, let's go back to our data service. Look at the constructor here. This constructor requires an HTTP object. So when creating a data service object, we need to provide an HTTP object. Now back in post service, because post service extends data service, when we create a post service object, first we need to create a data service object. This is how inheritance works. So in order to create an instance of a derived class, first we need to create an instance of the base class. So here in the constructor, we need to call the constructor of the base class. And for that, we use the super keyword. So super, and we call it like a function. Now here we need to pass an HTTP object. So this HTTP object that we have as a parameter to this constructor, I'm going to simply pass this to the base class, HTTP. And the compilation error is gone. Now we're almost done. The last step is to fix the issue with the URL. So let's go back to our data service. Here in the constructor, I'm going to add a new parameter, private URL of type string. So I want the classes that derive from this data service to supply this URL. And this way, we can reuse this class in multiple places. Now we have a compilation error because we have defined this URL field in two places. So delete. Beautiful. Now we have a reusable data service. So let's go back to our post service. Here we have a compilation error because we have not supplied the URL. So I'm going to get this URL here and pass it when calling the constructor of data service. And we are done. Now with this implementation, you can see our post service has only 3 lines of code. And next time we want to create another service like course service or author service or tweet service, we don't have to repeat all this implementation here. Okay? So back in post service, let's do the final cleanup. We no longer need the catch and throw from observable. We no longer need the observable type. We no longer need these application specific errors. Delete. All we need is these 3 import statements. Much cleaner. Now the final step. Let's go to our posts component. We have a few compilation errors because we changed the name of our methods. So instead of get posts, we should call get all. And similarly, instead of calling create post, we should call create. Instead of calling update post, we should call update. And finally, instead of calling delete post, we should call delete. Now let's test the application. So here we have all the posts. I can add a new post. Beautiful. And I can delete it. And we get this error message. This post has already been deleted because we're sending an invalid post ID. So now we have a reusable data service that we can use in multiple places in one application or across different applications. Okay, we still have one tiny issue here in posts component. So in all the methods in this class, where we subscribe to our observables, we're working with a response object. And as I told you before, we don't want to work with the response object in our components because we added this service to encapsulate all the details about working with HTTP services on the backend. So here, Ideally, instead of getting a response object and then calling the JSON method on it, I want to get an array of objects. So let's see how we can do this. Let's go back to our data service. Here in the getAll method, I'm going to use one of the observable operators called map. With the map operator, we can transform the items in an observable. Let me show you how it works. First of all, on the top, we need to import this observable operator. Because as I explained before, these observables have lots of operators and they are not available by default. This is because they increase the size of our application's code. So we need to import only the ones that we really need. So here, I'm going to duplicate this line and change catch to map. Now back in getAll method, once we get the observable, we can call the map method. Here we get a response, and then we immediately call response.json. So we're mapping or transforming this response object to an array of JavaScript objects. Okay? So now let's go back to our component. With this change, instead of getting a response here, we get an array of objects. So I'm going to rename this to posts. Okay? Then we don't need to call the JSON method. Now, because the body of this arrow function has only one line of code, we can get rid of these ugly curly braces here. And we should also remove the semicolon. And now we can make this a little bit cleaner by putting all this on one line. So, like this. Look, it's much cleaner than the code we previously had. So now as an exercise, I want you to modify all the methods in this component and replace the response object with the actual JSON object that is returned from the server. So go back in the data service and use the map operator in all the methods in this class. Now here's my solution. So here in data service, I'm going to copy this line, map, and simply duplicate it in other methods in this class. So here in the create method, we map the result and also catch any potential errors. Now similarly, in the update method, we're going to map the result and also here in the delete method. Okay, now back in our posts component, in the create post method, instead of getting a response, we get the actual post object that is returned from the server. So I'm going to rename this to new post. And here we can simply access new post.id. Much better. Next, here we have the update post method. So in the subscribe method, instead of getting a response, we get the updated post that is returned from the server. And then we can simply log it on the console. And finally, here in delete post, when we delete an object on JSON placeholder, we don't get anything in the response. So the body of the response is an empty object. So here, we can replace this with empty parentheses. So this is the final result. We have a clean component with good separation of concerns and proper error handling. Now, if you haven't been coding along with me, I've attached the code for this component and our services to this lecture. So download the code and review it on your own. In this lecture, I'm going to talk about optimistic and pessimistic updates. Now, if you're not a native English speaker, you may not know the meaning of these words. Optimistic means hopeful, whereas pessimistic means hopeless or negative. What do I mean by these? Well, look at how we have implemented the create post method. So when I add a new post here and press enter, this post is not placed in the list until we get a successful response from the server. And as you will see now, this is going to take about half a second. So there's going to be a little bit of delay from the moment I press enter until this new post appears in the list. Let's see. Did you see the delay? One more time. Okay, there was a tiny delay, like about half a second. This is what we call pessimistic update. We are hopeless. We are negative. we're assuming that the call to the server will probably fail, and we will only add this item to the list if we get a successful response from the server. In contrast, we have optimistic update. So instead of waiting to get the result from the server, we update the user interface immediately. We assume that most of the time, the call to the server is going to succeed. Now, if that fails for any reasons, then we're going to roll back our changes. A lot of modern applications these days use the optimistic update approach because that makes the application appear faster and smoother. So let's see how we can implement optimistic update here. Back to our posts component, in the create post method, you can see that we are updating our posts array upon receiving a successful response from the server. So I'm going to get this line, cut it, and move it right here. So as soon as we create this post object, then we immediately update the posts array. Next, we clear our input field, and then we will call the server. Now, if the server responds with a successful message, then we'll set the ID of this new post. Okay? Now, otherwise, if something goes wrong, I want to roll back the changes. So I want to remove this new post from the top of our array. So we would write something like this. This.posts.splice. We're going to go to position 0 and delete one item. That's it. Also, in terms of code formatting, note the space between this line, which is about updating the user interface, and the next line, that is line 37, which is all about error handling. So the lines that are highly related should be close together, and they should be separate from other lines. As another example, look, these two lines are highly related. We create this post object and then we immediately use it. We place it inside this posts array. But these two lines are separate from clearing the input field. That's why we have a line break here that makes my code more readable. Okay, now let's test this. So back in the browser, this time, when I add a post, you will see it appearing in the list immediately. So mosh, enter, there you go. Book, see, it's a little bit faster than what we had before. Now let's simulate a scenario where the call to the server fails. So I'm going to open up data service. Here in the create method, instead of calling the server, I want to temporarily return an observable that has an error. How do we do that? You already know that. So we return observable.throw and add an error object here. Now, as I told you before, throw is a factory method that we use to create a new observable object. And this will return an observable that includes an error. Now, in this case, that error is an app error object. Now, let's comment out these few lines. Now, let's go back to the browser. I'm going to add a new item. So we got this error, but Mosh didn't appear in the list. In fact, it did appear, but because the rollback happened so fast, you didn't even see it. So now here's an exercise for you. I want you to pause the video now and change the implementation of the delete button and use optimistic update. Now here's my solution. So back in post component, in the delete post method, I'm going to delete this post straight away. So I'm going to get these two lines, put them here, then call the server. Now here we don't care about the successful message that we get from the server. So instead of passing an empty arrow function, we can pass null. However, if something goes wrong, you want to roll back the changes. So I want to put the post back where it used to be. Once again, we use the splice method. So this.posts.splice. We want to go to this index. We are not going to delete any items. Instead, we want to add a new item, and that is this post object. So this is how we can roll back the changes. Now let's test the changes. So back here, delete. You can see it got deleted faster. Much better. Now let's simulate a fail scenario. So back in our data service, I'm going to temporarily return an observable with an arrow, new app arrow, and then comment out these few lines. Okay, back in the browser, delete, we got this alert, and the item is still in the list. Beautiful. So as you have seen throughout this section, when we work with backend services, we are dealing with observable objects. Now, earlier in the course, I told you that we use promises and observables to work with asynchronous operations. And if you have worked with other JavaScript libraries or frameworks, chances are you have worked a lot with promises. So you might be wondering why Angular team have used observables instead of promises. So in this lecture, I'm going to show you the difference between observables and promises. So to focus on one thing, I'm going to modify the code in the delete post method in our post component. Let's not worry about updating the user interface or error handling. So I'm going to delete all this code and simply call the server. So this.service.delete, and we give it post.id. Now let's see what happens if we don't subscribe to this observable. So save, back in the browser. I'm going to delete a post here. Now let's take a look at the network tab of Chrome Developer Tools. So here are the requests sent to the server. We have one request to get the list of all posts, but there is no request to delete that post. What I want you to pay attention to here is that with observables, nothing happens until you subscribe to them. In other words, if we simply call the delete method here, our service is not going to call our backend. This will only happen when we call the subscribe method. Let's try it. Save, back in the browser. I'm going to delete this post. Now let's take a look at the network tab. Okay, now we have a request for deleting this post. So you can see a delete request to this endpoint. So this is one of the key differences between observables and promises. Observables are lazy. In other words, nothing happens until you subscribe to them. Promises, on the other hand, are eager. So as soon as you create a promise, the code is executed. So let's go back to our data service. I'm going to change this delete method, and instead of returning an observable, I want to return a promise. So we can always convert observables to promises if we really want to, but this is something that I don't recommend you unless you have a strong reason to do so. So prefer to work with observables, as I will tell you later in this lecture. So here, just like we have the map operator, we have another operator for converting an observable to a promise. First, we need to go on the top and import this operator. So here, I'm going to duplicate this line and change the name of the operator to toPromise. Now back in the delete method, I'm going to add this operator here, .toPromise. Okay. Now back in our component, you can see we have a compilation error because promises don't have a subscribe method. So here we have only two methods. Then for getting the result, and catch for handling errors. Now here, I'm not going to call then. So when we go back to the browser and delete a post, you will see an HTTP request to delete this post. Let's verify this. So delete. And in the network tab, you can see here we have a request for deleting this post. So promises are eager. We don't have to call the then method. Whereas observables are lazy. Nothing happens until we subscribe to them. Now you might be wondering why observables are lazy. The answer lies in the operators of observables. So back in our service, so far you have seen a few operators that are available on observables. There are lots of other operators for performing arithmetic operations, for working with timers, and so on. These operators are very powerful. They allow us to implement certain features with only one line of code. Let me show you one more operator. So instead of toPromise, I'm going to call retry. This is a very powerful operator. So if the call to the server fails, this observable will retry 3 times. Now, if you want to implement this feature in a traditional way, you know that as a minimum, you need a for loop, you need some variable to keep track of the failures. It's going to be at least 4 lines of code. Whereas here with this observable, all we have to do is to call the retry operator. There are lots of other operators, and these operators allow us to implement certain features with far less code. This is what we call reactive programming. So reactive extensions, or RxJS, which is the library where we get these observables and their operators, these allow us to write code in reactive style. So we simply create an observable and apply a bunch of operators, and then we will get some feature that is far more complex to implement the traditional way. Now, once again, this is an entirely separate topic. It's beyond the scope of Angular, and you don't really need to know that, because as an Angular developer, the 2 operators that you use most of the time are map and catch. Now, here is the key things I want you to take away. With observables, we have these powerful operators that do not exist on promises. And these operators only come in effect when we subscribe to an observable. That's why we can chain all these operators like map, retry, catch, and nothing happens. So when we call the map function, nothing is being mapped. All we are doing is programming this observable. So we can chain all these kind of operators, and later when we subscribe to these observables, all these operators come in effect. This is very powerful. So to wrap up, remember that you can always convert an observable to a promise, but prefer observables to promises because they're very powerful. They allow reactive programming. They provide a bunch of useful operators. And remember, observables are lazy, which means nothing happens until you subscribe to them. All right, now it's time for another exercise. I want you to use what you have learned in this section and build a page like this. On this page, you can see the list of my followers on GitHub. So in order to render this page, I've called one of the GitHub endpoints to retrieve the list of my followers. Let me show you that endpoint. So here on the network tab, you can see there is a request to this followers endpoint. And here's the actual URL. So https://api.github.com/users/mosh-hamedani/followers. When you hit this endpoint, you get an array of JSON objects like this. So for each user or for each follower, we have these properties. I'm using avatar_URL to render their picture. I'm using HTML_URL to add their address, and login to display their username. And here's the output. So we have their avatar, their username, and their address. So go ahead and build this page. Next, you will see my solution. All right, let's start by creating a new component. So ng gc github-followers. Okay, next we need to create a service. So ng gs, once again, github-followers. Okay, now let's go to our new service. So github.service.ts. I want this class to extend our reusable data service. So extend data service. Let's import this type. Okay. Now here in the constructor, we need to get an HTTP object and simply pass that to the constructor of the base class. So super. Now here, the first argument is the URL. So https api.github.com/users/mosh-hamedani/followers. And then we pass this HTTP argument. Okay. And finally, let's import the HTTP type. We're done with this service. Beautiful. Now let's go to our new component. So github.component.ts. First, we need to inject this new service. So service of type GitHub followers service. Now, in order for this to work, we need to register this class as a provider in app module. So let's go to app.module. And here in the providers array, I'm going to add GitHub followers service. Pretty simple, right? Now back in the component, here in ng-on-init, we want to get all the followers. So this dot service, well, we need to apply the private keyword here. Okay. Now get all. Then we need to subscribe to this. Here we get all the followers. And then we can set a field like this. Very easy. Let's define this field. Followers of type any array. We're almost done here. Now let's build the template. So github.component.html. Here I'm going to use the Bootstrap media object. So if you go to getbootstrap.com, under components, if you scroll down, under media object, here we have some sample markup. So with this markup, we can render layout like this. This is a very common layout that you see in a lot of social networking websites. So let's copy this markup. Back here in our template, let's paste it. Then we apply the ng4 directive to repeat this. So let follower of followers. Now for the image, we're going to render follower.avatar_URL. For the heading, you're going to render their username. So follower.login. And finally, instead of ... we're going to add a link to their page. So I'm going to add an anchor. Here we render follower.html_URL. And we're going to use the same property as the value of the href attribute. Now finally, we need to use our new component on app.html. So let's go back to our component one more time and simplify the selector. Remove the app prefix. I don't really like this. Imagine in your application, you have 50 components or 100 components. In your templates, everywhere you see app dash, app dash, app dash. It's just too much noise. Use it if you really need to. This is not a best practice. So finally, let's go to app.html. And here we add GitHub-followers. Okay. Now back in the browser. So this is what we get. Because these images, these avatars are in full size. We want to make them small and round. So let's go to github.component.css. Here I'm going to define a class called avatar. Set the width to 80 pixels. Same for the height. And apply a border radius of 100% to render it as a circle. Now let's go back to our template. So here's the image. I'm going to add one more class here, avatar. Save. Back in the browser. And this is what we get.